Oh, someone says double dot means in the referring to this one, referring to this. No,
Onabada, the good idea would be to actually repeat a bit of the RE module anyway, because
just
there were
yeah,
a lot of questions on that.
RE module, right? Okay.
And preferably, if you could show them directly on the interpreter, it will be complicated perhaps, but then it will be easier for them to follow.
Not the interpreter. I go here because
yeah, it will be difficult to type all that.
Can you see? This is the first program that I said. So this is my import RE. This is a string. I wanted to find out some substrings present there which starts with C, anything intermediate, just one character, anything intermediate, and ends at T. So that when I run this. Oh, I have to print him. Gives me all those things present in the string which starts with C, ends with A, ends with T, and anything in between.
Any one character you mean?
Any one character. And if I want not one character, any character, I will just give if not one character, any number of characters. Anything, any time. So I have to give a star any number of times. Anything, any number of times. So give this. And then type print m. Now this is a long string because I allowed any number of times. So if from this C to this T, everything comes under this. Any number of times you could find. So I get this. Okay, so this is it. So if I have to be careful because I said anything, any number of times. So it found the largest one, putting everything between this C and this T. And I can specify, no, I want, say, for example, no, that is a question that somebody raised, that now first dot means that you put one character, anything. Second dot means you can put one character or no character, because the question mark stands for 0 or ones. So one first dot will always put one character. Second dot may put one character, may not put one character. If it's not, I mean, it can be 0 or 1. If
so
we do that,
so the dot actually means one character, but the question mark makes repeat either 0 or 1 times.
Right, yeah.
So double dot is really would have meant 2 characters. But here it's not really double dot.
First dot is for anything. I mean, first dot I give a free hand. You put any character. For the second dot, I say you can put one character here, or you can put no character there. So actually, I allow for 1 or 2 characters. Is it okay? Because this, for the second dot, it may put a character if it finds, but if it doesn't find, it won't put. So this dot can put 1 character or 0 character. So there is place for maximum 2 characters, but even here the second dot, no character will also do. So I can either get 3 character or get a 4 character string. Is it clear? So that is why 2 dot. I mean, first dot is a freehand, second dot comes with a qualifier.
I think it would be better if you showed them a C dot question mark.
Sorry?
Okay. Show them a C dot question mark, then.
Okay. You mean not the first one, right?
Yeah, just C dot question mark T.
C dot question mark.
There may be none, but there are quite a few. But there's
no
C.
Question mark. Yeah.
Is there a CT somewhere? Yeah, there is a CT.
You can put 1 character or put no character. Okay. Write a print him here.
Write a print him here. That would be better.
See, if the string that I chose didn't have two C's, yeah, there was two C's altogether, but it didn't fetch it either. Oh, yeah,
No,
CCT.
CCT.
It
So
is
CCT,
CCT.
it's already gone in that, right?
There was no CT. Let us introduce one CT there. Huh?
Introduce a separate CT. Yeah.
CT. Yeah.
By the way, most of these expressions are greedy in the sense that if they can get the biggest thing that fits, then they will do. So although CT also fitted earlier, because there was a CCT possible, it actually gave you CCT.
Now, see, I've introduced one CT over there that has been fetched out. CT. Because now this dot is anything, you can put one character or no character. So CT is already also fetched out. Is it clear? I give one CT here, so without any character, that is also allowed, because in the intermediate character can be one character or no character. So CT is also allowed. So that is it. So any other question?
You can unmute yourself and ask.
Sorry?
I think the audience can also unmute and ask at this stage if you have a question.
Yeah.
Okay, Shamal is asking what happens in this case if I use a string like CCCT. You will see CCT. Or yeah, he is asking if what happens if you have CCCT. Let's say more C.
Just CT, for example.
No, not this one. Not this one. The point is, just leave it a C dot question mark T.
C dot question mark T.
But in the original string, suppose you had CCCT for 4 C's and T. Then what will
CCC, right? This one.
Yeah.
Let's see. I don't think, because it has to find C. So start with C, end with T.
Yeah.
It has to start with C, end with T. So I don't think there will be any.
There will be no change really in this case.
Change at all.
Run it.
Oh, yeah, because this city is missing, because it is now referring to this one, you see?
Yeah.
I was not finding this. Because of CCT, it is finding.
Yeah, the point is, RE is greedy in the sense that it will make the largest possible fit.
Right.
So although CT also fits,
Huh.
CCT, the same CT is part of a CCT, and if a bigger thing fits, it is going to take the bigger thing.
Right.
I think what you need to do is perhaps repeat the dot question mark a bit again. There was somebody else is asking for the dot question mark.
Huh. Dot question mark, yeah. What is the question?
No, just an explanation.
Oh, as I said, you know what it is. What does this mean? That you start with C, end with T, and in the intermediate location, you can maximum put one character or no character. What are the matches? That was my question. Now, if I put this one, then there are two dots. First dot say that you can put one character of anything with no qualifier. For the second dot, there is a qualifier. So means you have here the second dot with the qualifier. Here you can put one character or no character. So it will at least have three characters: C, the first dot, and the T. And if it finds something, another match with another character in between, it will also find that out. Okay.
Ahmed Terin is asking for an explanation about global variables, I guess. But if you're done with the RE, then we can go there. Repeat what a global variable really is.
Global variable here is that something that you don't define as a local variable, but in the namespace it is already defined. So we could use that.
Okay, if I can elaborate on this a bit, the arguments which you pass to a function are always treated as local to the function. That is, no matter whether variables with the same name exist
Exactly.
in the global context. Suppose maybe you could give an example, or if I could just try myself. Will I, or you have an
Yeah,
example
you
ready?
take over. You take over.
Okay, I will just take 5 minutes for this.
Okay.
Okay. So, okay, it may be a bit confusing to people because you may be seeing the same name for both of us. Arunabha and I are both logged in from the same account, so that's why it may seem to be who is taking over from whom, because it seems it's the same thing. But anyway, now, okay, let me just show you. Okay, let me just show you this. This is a basic no-frills Python interpreter. Somebody was asking, can we do this in Spider? Can we do this thing and in some other interpreter in idle and so on? Most interpreters come with some extra stuff that they do at the beginning when you start them. So they give you some extra advantages over a basic Python interpreter. I personally like the basic interpreter a lot because it gives me a lot of control. Okay. So let me just start this. Okay, this is a Windows version, so I'm not very sure I understand how this works all the time, but let's see. Okay, so this is the interpreter. And let's say I'm defining a function here. Let's say return 8 times x. As simple as that. Now, right now, I've not done anything after opening the interpreter, so there are no variable names defined right now. So if I try something like, but if you look at the dir, the directory, only new name that you will see. Okay, somebody is asking me to increase the font size. Can I do that easily? I don't know. Unfortunately, this is Windows, completely outside my domain of expertise.
No, make it full screen.
Even if they're asking for a bigger font size, how does one change the font size? There is properly found it. Font. That should work. Is that okay?
It's okay, I think.
Yeah. So if you look at the directory right now, you can see that apart from the names that came in when I first brought in, all these double underscores are special names. The only name it knows right at this stage is f. If I try f of x, I'm calling the function f, which I've defined, with an argument x. I of course get an error because it does not know what x is. If I try f of 10, or say f of, then I'm giving the value for this variable, so no problem there. But I still get an error because when it tries to calculate f of 10, it has to return first calculate a into x. It does not know what a is. And realize that there is no a defined inside the function. So function's local namespace has no a defined in it. But what I can always do is I can define the value of a outside and then call. It does work fine. So here, the way in which Python works is this. Python starts out by, when you call a function with an argument, Python looks for all the variables. So first of all, the argument that you have supplied, automatically the value gets copied to whatever this x is. So this x is a local variable for the function. It knows what its value is. Then it tries to look for other variables. It needs to do the calculation. Right now, it needs to calculate a times x. And a has not been defined inside the function. But what Python will do is that it will look at the next higher level. That is, whoever called the function, in this case, the main program, is just going to go back to that and ask, okay, what is the value of a? So in this context, that's what the global variable means. Okay, however, there's something a bit more to it. So let me just define the function again slightly differently. What I've done now is that I have redefined the function a is 4 inside. I'm returning a into x. Now, even if I have a 10, and I try to calculate f of 3, let's say. So 10 times 3, of course, is 30, but what I will get is not 30, I will get 12, of course, because a is 4 inside. But what is important is that this variable a, which has been changed inside the function, is a local variable to the function. It has no connection with the global variable a, which is defined here, which is why the global a is still 10. So even though the local a is 4, the global a is 10, and the function, when you call it, does not change your global variables in any way. This is very important because when you are running a function, very often you will be using functions which somebody else has written for you. And inside the function, there may be many variables which are being changed to do the calculation. Now, if it so happens that some of the names match your names of the whatever names you are using for your variables, and they were changed by the function, you would have no clue why they have been changed. And it would be very difficult to write any program. So this is the basic point, that the fact that there is a clear distinction between a local namespace and a global namespace actually makes it very safe for you to run the program. Now, Tanaya is asking, if I want to change the value of the global variable, what do I do? First thing, unless you have full control of your program, that is, you know every piece of your program, every function which is going into it, changing global variables is a dangerous idea. You should never do it. Why? For the simple reason that if you then give your function to somebody else to use, that poor fellow may have that variable with some other name, for some other purpose, and your function might change its value. However, there is a way. It's not advisable, but you can do this. And declare a variable to be global inside. But you can do something like this. Now what I've done is I've explicitly declared that the variable a is global. That means I've told the function, do not look for a in your namespace, look for a upstairs. So a is, suppose I start again with a is 10, I run f with the argument 2. What happens is, of course, it looks for the global a is 10, but it reduces a by 1, so a becomes 9. So you get 18, but what is important is a also changes. Every time you run this function, next time a is 9, a gets reduced by the function itself to 8, so you get 16, but a also changes. This is something you can do by declaring a variable as global, but this is definitely not advised unless you are sure of what you are doing. On the other hand, let me also say one thing which will be useful later, which is this. By default, ordinary variables like integers, floating points, etc. are by default local, unless declared to be global. That is, variables which are used inside a function, either as an argument or calculated inside a function, that by default local. The exception is lists and strings. Oh, sorry, not strings. Strings you cannot change anyway. Lists and arrays, which you will meet later, these are actually global by default. So later on, if you write a function involving a list as an argument and you change the list inside the function, the global list will also change. This is something you have to be careful about. Why is that the case? That's simply because it's a case in most programming languages that ordinary variables are passed by value. Their value is copied, and the lists, etc., are passed by reference. Their actual memory location is given. Copying the value of a list for a local copy might be very expensive. So that is why because a list may have many entries inside it. That is why by default lists are always passed by reference. That is, I don't understand what a locally global variable is. Means defining a global variable limited only to a number of subroutines. No. And usually, as I said, global variables, even across subroutines, there are no subroutines in Python, by the way. That's an explicitly Fortran thing. And in most modern systems, you don't need such things. Fortran, of course, was designed that way because it was designed when computers were very rudimentary. And they had to fully exploit various loopholes in this, and frankly, most modern systems don't allow these things at all. Okay, Arunabha, okay, defining a function by lambda. I think Arunabha, are you still there? Arunabha, are you still there? Or?
Yes.
So would you take over the lambda part?
Lambda part, okay. Lambda part I've already shown, I believe. Can you see?
Yeah, you can. I will have to stop presenting. Yeah. Okay, there's just one more question right now. If we do not define global or not assign any particular value inside the function, then it is local or global. The answer is then it's an error. You get a name error. Computer just the interpreter complains that I don't know what you mean.
Right.
So the point is, if it looks for the local variable. If it can't, it looks for a global variable. If it's not defined, even there it says I can't find the name. You get a name error.
Lambda function is when you want to define a function, but not through this def kind of thing, but just a single line like f equal to lambda. Lambda is a keyword. Lambda of x such that x square. That is how you can define a function. The function is actually x square. It returns x square. So f is defined. So say my x is 5. So I call f of 5. It gives me 25. That's it. So this is a lambda function. I can define it without going to the def one. It's a shortcut definition of the function. That's it. Now, I want to show you something before going. I said that I will be discussing class and all, but before going there, I want to.
There is a question. Shamal is asking, is it what is the advantage of lambda? And another question, is this limited to mathematical functions? The answer is no.
No. Yeah.
Mathematical functions are simply the ones we understand the best, I guess, we as physics people. But otherwise, it can be used for any kind of function.
Right. Okay. Now let's just show some more interesting thing. There's a function in the built-ins called filter. I am going to show you the use of the function filter, which is there in the built-ins. Say I have this is my list. I've generated a list from 1 to 7. I took different numbers and multiplied everything by 0.5, so I've got a list. And the output of this is x. Now from that I want this. So this is a list. So if I run this portion, for example, I run this block in the interpreter. So I don't know whether sine and cos are defined. Yeah. So x is some values. from 1 to 7 different numbers multiplied by 0.5. Now, among these numbers, say I want to pick up those numbers for which sine square of x is greater than cos square. I just want those numbers to pick up. So this is a kind of filter. My filter is I want to get only those numbers for which some condition is there, some function. So I define a function. This is my function. You can see this is my function. By the ff is function which takes x and calculates if sine square is greater than cos square, then my return is true, and otherwise my return is false. So what it will do, I operate this on this, like filter of x. First of all, run this. Okay. So this portion is blocked. So I run this portion of the program. So my filter is ff is defined. Okay. So this is my x. It is this, and I ran this portion also. That I operated. Done. I am going to operate the filter. So I run filter of filter by ff on x. X is my list, and ff is the filter that I apply. It says it's a filter object, so I want to convert it to a list. So it gives me only those. What it does, it applies the ff function to every element of this x list, and the ff function, what is the output of this ff function? Look, it returns either true or false. So for those elements where you get the true, you include that in your output, and for which it is false, it is not included. So you filter out, you reject those entries for which the return is false. You allow only those entries for which return is true. So that is the filter. So it says that 1, 1.5 and 2 are those numbers for which this condition sine square is greater than cos square. So that's a nice way of filtering out something depending upon some condition. Okay. Now I'm going, so I run the whole program. It gives me this is my output, filter output, and for verification I just generated squares of sines and cos as a dictionary. So first entry is the sine square, second entry is the cos square, and it gives me the chance of verification whether it got me right or the wrong. So here I can see that I mean, going through this, I can see that it has got right. I mean, only those, it gave me only those numbers for which the sine square is greater than the, see the second, it says this one is the second entry here. 0.7 is the sine square, 2.9 is this, 0.29, so sine square it is greater than cos square, so it gives me the entry. So that is how filter gives me, depending upon some condition in which the return is true, only those are remaining, and those for which the output is false, those are rejected. So I'll show you an interesting use of
Could you just repeat the filter part? I think people miss exactly what the filter is in all that.
Filter takes two arguments. First of it is a function, and second of it is an iterable, say a list. And it operates the function on each element of the list, right? And the function has a property that it returns either true or false. For those elements for which this return of this function is true are kept, and for which the return of this return from this function is false are rejected. So
Arunabha, Could you try increasing the font slightly? Apparently, some people are
Is
finding
it?
it difficult to see. Slightly, because it's already,
Okay.
I find it's big enough, but
Tools preference, appearance, 30.
okay. One suggestion to everybody, please change the mode to spotlight. Just change the layout to spotlight. In that case, you will be
Is it
able to see
okay?
a much bigger screen.
I've changed it.
Yeah, here the font is big enough. I'm saying even otherwise, if you're not using the spotlight layout, your screen may end up showing too little, showing too small.
Sure. See, so ff is a function. First of all, you see, ff is a function which takes an argument, calculates something, oh, calculates something as returns either true or false. And then this if filter is a function which takes two arguments. First, a function. Second, an iterable. In this case, of list, and it operates the function on each element of the list, and then for each element the answer will be either true or false. If it is true, then it's kept, and if it is false, then it's rejected. That is what a filter do. Filters out some element. So if it is false, it is out. But the output of filter is a filter object that has to be converted to list. That is what I did in this example. That I don't know what is. Let me run it once again. So this is the original list. After filter, I got only this elements. My condition was sine square should be greater than cos square. So on each element of this, sine square and cos square are calculated, and for which those elements for which sine square is greater than cos square are kept, and others are rejected. That's it. And for verification, I calculated the sines and cosines also, so that I know that it did a correct calculation. Okay. And now I'm going to show you some interesting use of filter. It's a vector, not this one, prime. So I must say that this is an algorithm suggested to me by Professor Shivaji Banerjee of Calcutta, St. Xavier's College. The idea is that you start with, say, for example, the idea you have to generate prime numbers. Prime numbers from, say, a set. First I input, I give you a value, say 1000, and you have to generate all the prime numbers within from say 2 to 1000. How do you do it? There are many ways of doing it, and Shivaji's way is may not be the best way. I mean, it's just one of the way. It uses the filter function. That is why, as a use of filter function, I am showing you this. It is not definitely the best way to do it. So how do you do it? First of all, I define a function. What is this? I'll supply a quantity called div. Div is not a local variable, so it must be got from the namespace. Outside the function, there should be some value of div. It should take the value from the namespace, and the value of x that is received, the strikeout function receives the value of x, and it finds whether x is equal to div. You can say this is a condition. Return a condition. What is the output of this? X equal to div, either true or false. So the given x is equal to div, or the given x is not equal to. So if it is equal to div, this is true. Or x is not divisible by the div. Div quantity, x is not divisible. So x percentage div is not equal to 0 means x is not divisible by div. So what means that I'll give I have a quantity div outside my program, outside my function. There is a global variable called div, and I pass a variable x to it, and it will consider whether this x that I've passed to strikeout is equal to div or it is not divisible by div. In either of these conditions, either it is equal to div, then it will return 2, or it is not divisible by 2, then it will return the true. So true will be returned either x is equal to div or x is not divisible by div. So if it, otherwise say x is not equal to div or x is divisible by div, then it will give you false. Now see what I do. I first I have to generate the prime numbers. So you have asked me to generate prime numbers from 0 to from up to n, say. So I input n here. So this is my input of n, and then this is for timing. For the timing, you neglect that. So I generated a list. A is a list. A is a list. A is a list of numbers from 2 to n. Then from A, this is my A. So I generated all the numbers up to n is in a list. So I take each of the elements and set it as div. Set it as div. This element, say I set it as div and call this filter function. So what will happen? Say the first element of div will be 2. First element of A is a list, you can see. The first element of A is 2 definitely. So the value of I will be 2. Value of I will be 2. And then this filter function will be called with the value of div equal to 2. And will be operated on A itself. Will be operated on A itself. So A has is a list which contains 2, 3, 4, 5, 6 up to n. So it takes 2, and then it operates filter on that. So after operating the strikeout operation in the list itself, 2 remains, and anything divisible by 2 is rejected, because see, I allow only it is not divisible. So 2 remains, 3 remains, but 4 doesn't remain because 4 is divisible by 4. 4 is removed. Likewise, 6 is removed because it is divisible by 2. 8 is removed because it is divisible by 2. So all the multiples of 2 are removed. Okay. So by this operation, when in the first loop when I run, all the 2 remains, but all the multiples of 2 are removed. So I go to the next pass of this loop. I equal to 3. I equal to 3. So 3, when it is filtered, 3 remains, but all the multiples of 3 are removed. So next 4 is already removed. So I come to 5. 5 stays, but all the multiples of 5 are removed. Right? So if I do that, so I only have the prime numbers and all the multiples are already removed. So I run this for say small number first. Say I run this for 20. I only get 8 prime numbers, because first I got 2 and all the multiples of 2s are removed. I got 3 and all the multiples of 3s are removed. 5 on the multiples of 5s are removed. That is why I generate all this thing, everything. So I can run this, for example, for a larger number, say for example 1000. 168 prime numbers I got by this method. Of course, I don't want to claim anywhere that it's a very efficient method. No, it is not. It is not very efficient method, but it's a use of filter function. That is it. Okay. I think this is something that I wanted to talk about, functions and the modules. Then I'll come to something which is a slightly difficult concept, which is object-oriented functioning. Now, in the meantime, we have already seen things like complex. Python has complex, and Python can do, say, complex addition. We didn't show you that. Say, for example, complex of so 2 and 3 stored as A, Z1, Z2 equal to complex of 3 and 5. I didn't show you that Python knows how to add two complex numbers. Python knows how to multiply two complex numbers. Python knows how to take conjugate of a complex number. Right? So complex number is a quantity. Python knows what are a complex number comes with two components, and how to do the addition, how to do multiplication, how to do conjugation, etc. Similarly, we already know list. List comes with some numbers, and Python know many things: how to concatenate, how to find count, how to find. There are many methods defined on that. String also is a quantity. It has certain data associated with it, and there are many operations. And Python is already equipped with those kind of operations. It is equipped with some methods, right? So all these quantities can be called class. Complex is a class. List is a class. Set is a class. Dictionary is a class which is equipped with some data, a particular type of data, and it knows what different operations, certain types of data and certain operations. It already knows how to deal with this data. Now, therefore, these are class. And what is instance? For example, we know what is. If I tell you what is a list, list is an abstract concept. But what is this? Generally, if you ask you what is A, you should say A is a list. But technically, I should say A is an example of a list. List itself is a general concept. A is an example of a list. That is why we in this case say A is an instance of the list. So list is a concept, which means that it has some certain data, it can store certain data, it can operate certain methods on that, and A is an instance of this. And we can create another instance B, and we know how to deal with different instances. Now, like that, let us write a class vector. Apparently, basic Python doesn't have any class called vector. A vector which will be equipped with vector operations like vector of addition, vector subtraction, scalar multiplication, inner product, angle, etc. Can we do that? And our aim, let's say the aim, what you want to do is to go to this kind of a line, this section. I want to run this kind of a program. See, sorry. I will create instance of vector like this. We'll call vector, and I give 1, minus 1, 0 will be the component of a vector x, and 1, 1, 0 will be component of another vector called y. Like we create list, and then we'll call just print x dot y. That should give me the dot product of x and y. We should call x dot norm. That should give me the magnitude of the vector. I should call x angle y. That should give me the angle between the vector x and the angle between the vector y. I want to call x dot normalize. These are methods. This is my dream. I'm going to show you how to do that, so that it gives me a normalized vector along x. So a unit vector along x. I want to call something like y dot 3, which should give me the scalar product of y, a vector, with number 3. Can I do that? Can I write my own class, vector class, which having all those methods in it? That is my dream. Let's see, how do I do this? I tell you that this is a bit advanced thing. It may not be. I want to reduce the font size a little bit, 25. Yeah. Now, the first thing is that if I want to define a class, I'm going to define a class vector, right? So I have to start, like I define a function with a keyword. I defined a function with a keyword def. Here by keyword is class vector. So vector is the name of the class. Then a colon. Like all the compound sentences, I have to give the indent for rest of the body of the class. So if I'm going to define a class called vector with a colon, and then I have to give all the methods, that I want to define should be placed within the within indentation. Now, one of the important method that it has to definitely it should have is how to create an instance of the vector. How to create an instance, and this is a mandatory part of a class. You should have one such method, how to create an instance, and by default Python calls that the method, which is called the constructor, is the underscore underscore init underscore underscore init underscore, and self is the name by which it refers to itself. You have to pass some value to it. In this case, as I said, I planned to give the values components of the vector as a list. So I said that I will give a list to it. I'll give a list to it, and whatever list it gets, it will refer to as self.data. Self.data, it will keep the list that I supplied to that as self.data. That means that if I create a vector, for example, I just run this, import. Now, this is a class. This is a class I've already written, and this can be called a module. This itself is a module. So, like I import a class written in a function, or class, or any function. If you write in a file, you can call it a module. So I can import this. Import. The name of this file is small vector. So it is small vector. So I import a module. Right? Oh, it's not there, or what?
Or it should be the V should be capital, I guess.
Huh? No, the name of the file is small vector.
No, that depends on what you named your file. What is the file called?
Small vector. That is what I'm confused with.
So it's in some other place, right?
No, it's in it's my PyCos directory where I'm working with. Say, for example, I run this program. They're in the same directory. Yes. It's not okay. If it's not working, I can always do what
Why shouldn't it work?
should work, right? Import.
Is the name of the file vector.py? Small v?
It's a small vector.py.
Yeah, I think so.
I don't know why. Vector. No module.
Yeah, no, you have to initialize the module. Or usually it should not be needed. Usually it should not be needed. It should, as long as it's in your current directory, it should work.
Should work. That is it.
That depends, of course, on your setup. But I don't know. Usually it should work.
Okay, there's a way to bypass this. There's a way to bypass this. That I execute this.
You execute that, then automatically it has to come in. So.
I execute this, it is already bypassed. So the point is this vector is created. This vector class is created, and I'm going to, so I can, now you can see that my class is called vector with a capital V. So if I have to create a vector, that is I have to create, say, x equal to vector of, say, 2, 3, 1. I give this list, and this goes to as vector. Now, as I'm going to explain what is x self dot. X is the self, and I can retrieve this as x dot data. So 2, 3, 1 that I've given is now saved as x dot data, as x is the name of my instance and x dot data is x 2, 3, 1. So similarly, if I create x equal to say vector 2, 5, 2, so y dot data is now 2, 3, 5. You can see. So this is how I can create vectors, instantiate vectors. Now x is an instance of the vector class, and y is also an instance of the vectors class. So it is created. Now the question is, what should I do with them? Now let us look at this. This is subtract. Subtract is a function that I've defined how to find out the difference between these two vectors. As I know that my function takes a list, it doesn't care for the number of elements. I mean, it can be 2-dimensional, 3-dimensional, 5-dimensional, n-dimensional. So all I have to do a first component minus first component of x minus first component of y, second component of x minus second component of y, like thing. Now, as I have to give two vectors, the trick is that you give one self and date. You have to call with self and other, two vectors. One self and other is a vector, self is a vector. But as we have already seen, self is something you put dot on. So you have two vectors, x and y. So if you want to run this subtract method, it is called method, and like all methods, you can run it as x dot subtract y. You get something. So this is how you, although it seems that subtract takes two arguments, self and other. Self is the one on which you put the dot, and other is the one which you pass through the argument. So x is here the self and y is here the other. Okay. Now what is done here? Now it is simply, initially I create a new list, a blank list. Then I create range of lane of self dot data. I don't know how many components is this. I calculate the difference between the similar components of the self data. Self is x in this case, and the other data, which is y in this case. I find the difference between the similar components and I add them up on data. So data is another list which comprises of the differences of the similar components. And now I create another vector with this. How do I create it? When I write vector, you remember the way I generated this one, y equal to vector, x equal to vector. So that is how the new vector that is I generate with this data, I create a vector and return that. So here, if I store it as z, what is a z? It's a vector. So that is a vector, and I can do all sorts of operation with z. Okay, so this is one of the methods that I subtract is a method by which it's a name of the method, and I operate on the first one is self, second self dot subtract bracket other. That will be the way to call it. Self, whatever is the self on which I want to operate this. Say I operate x minus y, so itself will be x and this will be y, and the way to call it would be x dot subtract y. and then this is how I've defined this one, multiplication of 2. Say you can look at the program that I've multiplied this is a scalar multiplication. I've got a number. This particular method needs a number and then multiplies each component by the number and creates a vector from it. Multiplied each component by a number and creates a vector out of it. Okay, but the name is very strange with it. Instead of just anything very simple, I've used a very strange name, underscore mul underscore, because that is a reserved name. I can definitely call this function, this is a scalar multiplication. So for example, I can call this function as x underscore, let's see what is x first. X is this, and x underscore mul, because mul underscore 3. So I want to do a scalar multiplication by 3. Triple underscore. Yeah. It's done. So it's nothing much different. X, the name of the method is underscore mul underscore, and I supplied a number 3, and I got a scalar multiplication 693. But then why did I give such a complicated name for multiplication? Because this is a reserved word for Python. If I give any method the name underscore mul underscore, then there is an alternative way of calling this method. And what is this? X. So I can use the star sign, which is usually a multiplication sign, to mean this operation. So I am changing the connotation of the star sign, the multiplication sign here, by assigning a method to it. So that is the way I am changing the connotation of the star sign with a particular method. And this could be anything else. So whatever with underscore mul underscore, whatever method I write, that will be called simply by star sign. Similarly, therefore, this subtract, I should have given a different name. I didn't do that deliberately. There should be an addition, add. Yeah, see, there's an addition also. This adds 2 numbers. You can see the blank list is created, and then by looping over the elements, I've added the similar components of the vector and appended in a list data, and then created a vector out of this data, right? So it's fine. But the thing is, I've used a complicated name, underscore add underscore. Advantage that I call it with a plus sign. My x is defined, my y is defined, and I can call it by x plus y. Yeah. So vector addition. Now my Python knows vector addition. Vector multiplication, I deliberately, just to show you, I kept the complicated subtract name, which I can change easily. Now the other methods like say norm, dot product first, dot. It takes self and other, 2 vectors it takes, and calculates the dot product. Dot product is very simple. Dot product is very simple. You can see. Very simple. That I do it by a list comprehension. So I multiply by the similar components of self and others, and by doing a self list comprehension, and just return that. So that's it. I can calculate the dot product of this x dot y, x be the dot product of this. If I want to know whether it is going in the right way, I should give a good vectors, like vector in the xy plane first, say 1, 0, 0, and it's a list. The 1, 0, 0 should be a list. 1, 0, 0. It should pass a list to it. So 1, 0, 0 is x vector. My y vector is, say, vector 0, 1, 0. So I expect my dot product to be 0. Let's see what it is. Dot y is 0. So it is going in the right way. And then norm. You see, I can define a norm, which is, you can see what it is. I imported square root first from the math, and then I calculated the components from the list. I calculated the square of the components. That's a list. Then I summed it up. So sum of squares and then square root. So that gives me the norm of the vector. So norm of x dot norm, I can say, doesn't take anything. So this is this. X dot norm is this. And that is how I can define angle between two vectors, which is simple. That how the angle between two vectors are defined. It is the cos a dot b by magnitude of a, magnitude of b. So
I think it may be a good idea to pause at this moment. People, if you can give people the code for this,
yeah,
then
it is
they
there.
can take a look at this and maybe come back with a discussion later. Because
Yeah. That
might
is
end
better.
up becoming too difficult to just follow on the screen right now.
Yeah. That's it. That's a nice idea. So it is better that I stop here. So I mean, I just wanted to show you that I have written many methods here, which can be called for norm. I've shown you angle, shown you metric. Metric is the distance between a minus b, modulus of a minus b vector is metric. Normalize. Two pole is that for three-dimension vector. If you give xyz, it will give you r theta phi, etc. So many things are written. You can see yourself, and okay, we can have a discussion later on. Okay,
so
thank you.
We can then let people ask questions if they have any now.
Yeah.
Perhaps that will be better.
I think asking questions over this is a difficult. It's a difficult question topic altogether. So I rather, as I give you the slides, you go through the slides, and maybe tomorrow we can have a
So on class and etc. I think it's better to have the questions tomorrow.
Yeah.
Maybe today, what you can do is if you have any other
in the WhatsApp group also we can have a discussion.
True. Or if you have any other questions.
Yeah.
Given small example of class, well, this was a reasonably small example of class.
Yeah.
Any smaller, it will be rather useless. Okay,
and this is, I thought that there is there's a fraction of participants who are from physics background, and they will appreciate this particular class vector.
The point is you can write small classes, but if you just look at the first 2 or 3 examples, that should be enough.
Right.
May we have some other example of class? Of course we can, but maybe that's a bit too much for today. Maybe we can take it up later. In some definitions, you have used underscore. What is the meaning of that? That's a question. So,
why can't I see the questions?
You have to click on the chat on the top. Yeah.
Yeah.
Not that. Yeah. Yeah. Right. You can
Please mention. In some of definitions, you have used underscores. Oh, I think you are talking about these ones, right? Are you talking about these ones? This add, please pick up. Are you, please unmute yourself.
Yeah, so now it's possible to just unmute yourself and ask.
Unmute yourself and tell me, are you referring to this one?
Yes, yes, yes.
Oh, as I said that the advantage of giving such a, but not just one underscore, the whole name, underscore, underscore, add, underscore, underscore. This is a special reserved name, and that has the advantage that you can call this method in two alternative ways. One is simply x dot underscore underscore x dot underscore underscore add underscore underscore, or you can simply call it x plus y. If you want to operate between x and y, you can just call the plus operator. It's a
So
kind of
this
operator.
underscore will allow me to use plus sign.
Yeah,
Not just underscore, the whole name. Underscore,
Whole name.
underscore,
Yeah, yeah,
add
the full
underscore,
naming.
underscore.
If
Whole
I
thing is a reserved name.
if I
Whole
do
thing,
something else, then I have to use that word to do the summation.
Specifically, exactly. If you
exactly.
defined it something
Exactly.
as some other name, you would have to say x dot that name brackets y. But
Okay.
this
Right.
also allows you to use a plus as an operator. This is what plus operator means to Python.
Okay. Okay.
You should
This is
realize that the
that's
plus
the
As
sign
I
reason for
said,
that.
the meaning of the plus operator you are changing by this method.
Okay. Yeah.
So when you give plus sign between two vectors, automatically this method will be called.
Okay. Yeah. Yeah. Now I understand.
that's called operator overlaying technically.
So
Just means the
this,
same sign can be used for different purposes depending on where you are using it.
Arunabha, I have a simple.
Abhishek, it's better to ask questions out loud. You
and
can
this
unmute.
yourself.
Can you show the filter function once again?
Yeah. Filter function. The one this example, yeah. Yes. Are you talking about this? Hello, please unmute yourself.
Yes, I was. Is filter inbuilt inside this, or we have to import it?
Now, filter is there in built-ins.
Oh,
So you
Okay,
can
maybe
use filter. And for filter,
okay,
you
it's
have to
better
give
perhaps.
functions. You have to supply functions. You can use any function from any module, or you can write your own function. Filter takes a function and an iterable. That function can be one of the library functions, or you can define your own function also.
okay. Thank you.
Arunabha, I have a simple question.
Yeah.
In which situations object-oriented programming is useful?
Is vector is a good example, I said. I mean, if you want some kind of object, I mean, which needs some special kind of operations, and you do it with many often with multiple things like this. Vector is a kind of good example that you want to do it.
Okay.
I mean, before NumPy, before knowing NumPy, I used to define a matrix class. Normal, no, I don't do it now because I know NumPy. But before learning NumPy, I used to write a matrix class for myself, so that I can deal with the matrix operations, trace, determinant, etc. Now it is not needed because NumPy is there.
But knowing NumPy, will it be redundant?
Yeah.
You don't need matrix class altogether. No, everything with the matrix can be, most of the things can be done with NumPy. But vector still, I mean, it's not that easy. I mean, the angle between two vectors, for example, the normalize a vector, for example, then say, for example, you give two vector and you orthogonalize two vectors. If you want to have such methods, I mean, you can write your own
Not everything is always inbuilt in standard modules. Almost everything is, but not everything. You can always write your own classes to implement those. But of
right.
course, what Arunabha was doing here was sort of illustrating how to write a vector class. Now, usually, if you really wanted to do this professionally, you would do it by inheriting from the array class in NumPy, because then you will get also be able to handle all the
Right.
wonderful methods which the NumPy arrays have.
For example, you don't have to write addition, subtraction, etc. Dot product. Those are there in the NumPy class already, or NumPy
Okay.
array.
There was a question here which says, what is the notion of the angle in n-dimensional vectors? It has nothing to do with Python or computing, but let me just quickly give you the answer. The answer simply is this. If you form a dot product of two vectors in n dimensions, it simply means x1, y1 plus x2, y2 up to x and yn. That has an advantage, that obeys something called a Schwarz inequality. That's always less than or equal to square root of x square plus y into y square. Which means if you divide x dot y by the length of x and length of y, you get a number which is between -1 and +1. So if you take the cosine inverse of that and call that the angle between the two vectors, that's exactly how you define the angle. One advantage is, of course, if this turns out to be 0, then usually we would say the angle is 90 degrees, but in general we would say they are orthogonal. Is it physically significant? Of course, it's one of the most physically significant things you have. So this restriction to 3 dimensions is simply because we are seeing 3 dimensions around us. Faces, mathematicians deal with arbitrary number of dimensions all the time. So do faces, by the way.
So see, this can be taken as a definition, isn't it?
The cos inverse of that, of course,
Cos inverse of this, right?
as the angle. Whether you can picture that in your mind depends on how imaginative you are. But two vectors being orthogonal, even in infinite dimensional spaces, is one of the most important things that we have in physics. Almost most things that we have in quantum mechanics depends on that some way or the other. So, are they physically significant? Of course they are. Can you picture them as something you can draw? Or most probably no. But that's the advantage of using mathematics. Do we have to use file extension .py while defining a class? Not essentially, but unless you do it that way, it will not be found by your Python interpreter, then it will become a bit of a problem. It's better to have it as .py.
Another question we missed, what is map used for?
Arunabha answered this. I know the answer, but I ask you to do this.
Yeah, but I don't think this is relevant here. Did you describe map today?
No, I didn't.
Okay, then maybe we will talk about that when we use it, because otherwise it's going to be completely irrelevant right now. When I talk about the map function, I will use the map function later. I will talk about it then. Oh, in Lambda function it was used, was it?
Oh, yeah, slide it is used. Yeah.
You use it? Oh, I
Can
missed
you
that.
see? You could see my slide. Okay.
Oh, it was somewhere you didn't talk about it, but it was there somewhere in your.
Because I didn't follow the slides completely. Yeah. Perhaps this one.
Yeah.
Maybe
you can tell them what this map does.
Yeah. What it does, this is a function. Map is a function available once again in built-ins. It takes two arguments. First, a function, then a iterable. It applies the function on each of the elements of the iterable and generates generates a map which you can convert to a list. So it's like filter operates on each of the elements, and if it's found true, then only it keeps, and if it's found false, it rejects. But map operates on every elements of the iterable, and whatever value it found, it keeps. So it's like one way you can see it's something like a list comprehension. So it from X it takes all the values one by one and operates this for each of the values and generates a map, which can further be converted into a list.
Just to point out, this is one place where, say, the lambda function is really very useful. What Arunabha wanted to do here is calculate 1 by 1 plus x for every element in this capital X. Capital X, if you see earlier, has a list which is range 11. So it's basically 0, 1, 2, 3 up to 10. So what is being attempted here is calculating 1 by 1 plus x for every one of the values in capital X. However, what you need as the first argument is a function. So either you would have to define the function, some function name which returns 1 by 1 plus x, but maybe you have not done that, and maybe you don't really want to bother defining a function.
Actually, there are two examples. You see, this is an example where I used map with a predefined function.
Yeah, right. Here the function was already defined, but maybe you don't want to just go bother with defining the function all over again because it's a pretty straightforward function. So what has been done is you have defined an anonymous function. You did not bother naming it. You just said instead of where the name of the function should have gone, you just wrote down the function itself, and that you can do with a lambda. That is one of the major uses of lambda. Using a function which you need within another function instead of having to going and defining it elsewhere. We'll see plenty of examples of this before. Okay, I didn't realize that you had already used map somewhere, so I.
Actually, I used it and I skipped it. I used it in a slide, but didn't talk about it. But so someone is very careful and looking at my slides.
Okay, good.
Another question. Could you please explain POW with 3 arguments one more time?
Yeah. Now, as very clearly Anando said, that there are 2 POWs. One POW, I don't know. Do I have math here? So let us clear everything first.
Yeah, that's better.
Clear everything first. Okay. Now, I don't have anything. Only I can use those functions which are available in built-ins. In built-ins, there is a POW which can be used with 3 arguments. And in math also there is a POW, but that can be used with only 2 arguments. So there is a difference. So you are talking about the POW which is present in built-ins that says help on POW, that says that it can be called with 1 x, y, 2 arguments, and occasionally it can be also called with 3 arguments. I mean, if you like. And if you give 2 arguments, it just calculates x star y, x star star y, so x to the power y. And if you give 3 arguments, then it calculates x to the power y percentage z. So let's do it. POW, say 2 to the power 3 I want to calculate. So just this, 2 to the power 3. But if I give, say, 5, the third argument, this will mean calculate 2 to the power 3 and then take the remainder after dividing with 5. 5 is a third argument. You divide it with 5 and give me the remainder. And that should be 3, right? Yeah, 3. Is it clear? Somebody asked this question. Is it clear?
Professor Amitabh Sil was asking this question. I think
is it clear to you? Yeah.
So, okay, could you just go back a bit and show the help again? Because I want to use just the help. So somebody asked earlier, some variables are defined with none. So here you can see x comma y comma z equal to none. Now ignore the final slash, that is technical, that's not needed. There are only 3 variables here, x, y, and z. And z has a default value of none. What that means is that you can first of all call the function with either 3 arguments, x, y, z, or 2 arguments. Now, if you call it with 2 arguments, then whatever default value has been given to z will be invoked. Now, the point is, here you don't really want to give any non-zero value to z, because if you suppose if you give the default value, say, of 5, then wherever you call the function with 2 arguments, you will end up with 2, 3, 5 always. But you may not want that. You may want actually 2 to the power 3. So the none is a way of the function to realizing that, okay, I have not given a value for z, so I'm going to just use the 2 arguments themselves and not use z at all. Otherwise, if you did not have z equal to none, but you started say as z equal to 10, then of course you could have called it with 2, 3, 5. You have got 3. then any other choice would mean Z would if you just give two variables, two input, Z would always be treated as 10. And that's not what you want. Here you want to ensure that if you really don't give a third argument, there is no third argument. So this is, notice that it says equivalent to x over y when two arguments, and this with three arguments. So this difference in behavior when two are given or three are given, that actually is sort of forced because Z is given a value none. If you did not have Z equal to, then you would have to give a value. So you couldn't have called it with two arguments. You would have to always call it with three. But with Z equal to none, you can call it with three.
So you continue. I have a point to ask.
Oh, I'm done.
Tomorrow we have a joint session. Will you allow the first hour to me and then continue the rest with?
I have no problem. I have absolutely no problem.
So the first 1 hour I'll speak and then you take over.
Okay.
Arunabha,
Yeah, there's another question.
Please.
I have a question. I have not a question actually. Yesterday you were talking about telling us about nested loops in list comprehension. And I mean, I was trying it later, and this sort of worked. I don't know, like.
It works.
So I was wondering.
Suparna speaking.
It works.
Yeah, Suparna.
I recognize because I'm looking at my screen. I just from your voice I recognize you.
I sent the screen. I sent the code in chat. Mm-hmm. I was just wondering, like, is there some difference between Python 2 version and 3 version that it did not work?
It should work in all. It should work.
Yeah. Sorry.
Yeah.
Okay.
So
I was wondering.
Something else was going wrong that day. It should work.
Yeah.
In all. No, it is finally. I don't know why it is finally. It worked. I'll show you.
It would work. There was something which must have been mistyped somewhere. We couldn't spot that.
Right. Okay. I was just wondering whether there's a difference between 2 and 3
No,
somewhere.
No, at least in this respect, there is none.
Okay.
In this respect, it works in both cases.
Okay. Thank you.
Yeah. This one.
Yeah. Right.
No, not this one.
Not this one.
Yeah, this one.
Yeah.
This
right.
Huh?
Yeah.
And it should work.
Let's try this.
Yeah, straightforward.
Try this.
Right? So this should work, right?
Oh, you need A and B defined first. The only problem with that. They're already defined, right?
Oh, yeah. Thank you.
Thank you. Are A and B defined?
I was just blindly doing it.
Oh, A and B are not defined here, probably.
No, not at all.
Yeah, you tell them, right? It worked.
Yeah.
This has A has 3 numbers, or B has it's worked, and it should have given me 9 numbers, right?
Yes.
It should work.
Yeah.
Yeah.
So A0 into B0, A0 into B1, and so on.
And if like we put 2 box brackets and end one box bracket and then start and end the next one again, it should also give me a matrix of 3 each list.
Well, it should
right.
Yeah.
You get many times. Yeah. That is purity of the matrix.
It should give a list within a list.
Thank you, Arunabha. Thank you. I was just
I think there is no other question. So
I have a question.
Oh, okay, please.
Oh, please carry on.
Yeah, I have a question that whether that built-in functions we have to include it in our program or they work.
No. That's what. Which is something called built-in. You can use. It is free to use. You can always use it. And we are doing it. For example, when you clear everything, okay? Clear everything. Everything is cleared. Now I can give dir. No doubt. Where dir is coming from? Because it is built in. I can use dir. Okay. So everything. For example, this pow of 2 and I killed everything. You remember? The pow 2 3 is working. Where this pow is coming from? So the point is, anything which is in the built-in, it is ready to use. You don't have to bother, you just use it.
Okay. Thank you.
And by the way, this nomenclature, built-in or built-in, actually both of them should work because they're usually aliases of each other.
Mhm.
In most systems, it may be possible that
In
your
my case, it
interpreter
is not.
redefined.
Built-in are different two things.
Or
In
you
this,
can define them to be different, but by default, they're usually aliases. But it's possible for a particular interpreter to redefine it, and then it becomes different.
Okay.
But
We have
either way, built-ins are already always available. That's why they're called built-in.
Okay. Thank you.
we have 6 more minutes. If anybody wants to ask any question, please come forward.
please.
If there is no other questions, so let's thanks Arunabha once again for
Thank
this
you
Ananda,
very much.
please.
I believe.
wonderful session.
Okay.
Ananda, please,
And
please clarify the
yes,
built-ins again.
okay.
Built-ins.
And
Okay.
Ananda,
It's
is
for Anando. Okay, Anando will do that.
Why aren't they
Ananda,
anyway?
last line, what we told is not
Oh,
clear to me. Please
that last
clarify.
statement. That last statement is actually the name, whether the name is double underscore, built-in double underscore, or double underscore, built-ins double underscore, whether there's an S
Is
at the
it a
end of the
question
name.
raised by Hoimontide?
Yeah.
Yes.
Who's asking the
Yes.
question? Hoimontide, the question confusion was whether it should be built-in or built-ins. There are two names floating around, right? The Anando, what Anando is saying that those are alias of each other. In most interpreters, they're the same.
Some interpreters
you should be
can
Thank you.
define one for something else. In particular,
Okay,
built-in is always the one which is available. Built-ins can be sometimes changed to something else. Some interpreter may change it.
In my Python installation, it is built-in, and built-ins is something else.
Yeah, that might be possible for some installations. Built-ins can be changed, built-in cannot be. Built-in is the inbuilt thing always. However, frankly, for most users, that's never a concern. Because you will not usually be using the built-in module, you will be using what is there inside it. And that's always available to you.
any questions? Actually, I tried twice to stop the session, but question is coming. So so I wait for a while.
Thank you. Somebody is saying prime algo is nice. It's not my algo. It is Shivaji Banerjee's algo. Thanks should be passed on to him. Shuparna, please do that.
Yeah, it's actually the Eratosthenes thief, which many people may have already learned about in school. But that's it's an implementation of the Eratosthenes thief by using the filter thing, which is what makes it so special. That part is of course all Shivaji. The prime number algorithm is of course something which has been there for ages.
But it was Shivaji's suggestion to use filter function to implement that. So
Yeah,
I wrote it myself, but this suggestion was given to me by Shivaji.
I was just talking to Shivaji that today morning, telling him that I'm attending your sessions.
Yeah, I'm surprised why, Shuparna, you are an expert. You should be one in this side, one of the speakers.
Oh, come on. I'm really enjoying all your sessions. Lots of things
we are
that
honored.
are... Thank you so much. In fact, I wanted to thank you on chat, but I thought I'll thank you personally.
So finally, let's thank.
So finally, Kishore gets to close, right?
And thanks Ananda also for the support to Arunabha.
Arunabha will be there in all session to help us. I mean, me and AKG.
Okay.
Today, AKG is not
Ananda,
here.
your supportive discussion also is very enjoyable.
Right. And where is AKG? I don't hear him today.
No, AKG left because he may have had some network issues or something.
Oh, I see.
He left a while ago.
I see.
Okay.
Just around half an hour ago. He couldn't manage.
So we will come back again tomorrow at 3 p.m. sir. So
And CPM will start.
I'm here. I'm
and
here.
then-
I'm hearing. I'm going. I'm coming.
Oh, you come back.
Multiple times coming in and going out. I'm
You're back.
watching from.
I really
I'm watching
feel
from
it
mobile.
today.
That's why it's disturbing. I'm watching from mobile
Okay,
actually today.
okay.
Okay, I'm here.
Mobile gives you
Listen.
a better
Mobile is
voice
giving.
response. You know? I can
Yeah.
hear you much more clearly than others.
Yeah. Yes.
My mobile actually seems to be a better connection than my Wi-Fi. But anyway, so
Okay.
right.
Thank
Okay.
you
Okay.
all.
Okay.
Thank you all.
Thank you,
Leaving-
Arunabha. Thank you, Anando.
Calling it a day.